Good morning, everyone. I'm Meghna DK, and today I will be presenting our work titled Performance and Efficiency Trade-offs in Transformer Models for Kannada Sentiment Analysis. And these are my co-authors, Kiran K, Sahar, Miriam, Deepashana, and Venugopal KR, and it's presented by me. And let us go through the table of contents, which includes introduction, literature review, introduction to the transformer models, architecture, detailed workflow, dataset details, results, and conclusion. So, when come to the introduction, social media has become one of the primary platforms for people to share their opinions. Sentiment analysis helps us understand these opinions automatically, which is important for businesses, politics, and society. For high resource languages like English, there are abundant of labeled data, but for the low resource languages like Indian languages, we face some challenges like lack of labeled data and tools, and also a rich morphology present in the Indian data. And some dataset will be a code mixing with the English from the social media. So to address these challenges, we are using a machine translation using which we will transforming our English dataset into a Kannada dataset, and then we will putting this into a transformer models to try, and we are checking the efficiencies and the accuracies performance of these transformer models for the Kannada dataset. So let us see go through the literature review. In the literature review here, I have listed some of the papers I have referred for this work, and there is one work called as a Index Sentiment 104, which covers 22 Indian languages. It has been generated through a machine translation. So other works we can see here, they use the Indian languages like Kannada, Tamil, Malayalam, and they have used the models like LSTM, BERT, Distribird, Murid, Kbird, Henbird, IndicBird. All these models somehow generated the dataset using the machine translation and some other modes of cross-lingual methods. But all these papers performed the comparison between only the accuracies for the different models, but no papers have done the trade-off performance comparison for the transformer models. So here we have selected 5 different transformer models: IndicBird, DistilBird, MBird, XLMR, and Mural. IndicBird is specially designed for the Indian languages, but a multilingual version of BERT which is designed for 104 languages, and DistilBird is a smaller and a faster version of the BERT which is designed for the efficiencies, and XLMR BERT, a robust cross-lingual model trained on 100 languages known for a strong performance, but it is a little resource heavy, but it is more efficient and somehow accurate. So this is my architecture. In this, we can see first we have a English label dataset which is being Google translated into a Kannada label dataset, and this Kannada label dataset is used to train the IndicBird, Mural, XLM, RBird, Stillbird, and MBird models. After the training, the classifier heads that is connected to the class token is used to predict the sentiments, and these predictions will be used for the performance comparison of these models. And this is the detailed workflow. First, English dataset will be translated to Kannada dataset, and this Kannada dataset will be pre-processed and normalized to remove the unnecessary or not required data. Next, these labels will be encoded into a numerical labels because uh, when we can translate it, some of the labels may be difficult for the models to train up. So what we do, we convert it into a numerical labels, and then we split it into training set and the test set. Then we fine tune the transformer models in Mural, Imbert, XLM bar, IndicBird, and DistilBird. Evaluate these models and compare the efficiencies. Next, dataset details. We have created a balanced dataset of 3,885 entries. Each class of positive, negative, and neutral has 1,000 to 95 samples. Example, and the dataset what we created, the example is English. If we have I really like the song Love Story by Taylor Swift, it will be converted, translated into the Kannada dataset, and then its sentiment and the sentiments code, the numerical labels will be created. This will be done for the creation of the Kannada dataset. Translation solves the data scarcity problem but introduces some of the errors and vocabulary mismatches. Despite that, it solves the problem of the scarcity of the data that is very much required for the low resource languages. Next, then let's go to the results. Here we can see that XLMR has given the best performance in terms of accuracies. Viral is the next one, and IndicBud gives us the least result. And the reason for this is XLMR and Viral are the larger models and runs better, but IndicBud is a lightweight model and may lack in the dataset, may lack in the results of the accuracy. But when we see the rate of accuracy, IndicBud gives the best results because it takes only the 0.015 time seconds for the inference time and the 400 MBs of the memory unit. So it has very fast. It is a very ideal for the Indian languages. But we can see the XLMR, which gives the better results, takes the much memory and also take the more uh, the embed and XLM takes the more time, more inference time. So when we have the better resources, then only we can use these models. Otherwise, it is difficult for these models. So here, when we see the, so here I have included the confusion matrix of XLMR and IndicBud because XLMR is the better results and IndicBud gives the less results. As we can see, the neutral is giving the very less results when compared to the other one. So for that reason only we are lacking the, means in XLMR it is giving wet, but in a IndicBud you can see the neutral class is not performing better. So for that reason only the accuracy is dropped. So if you see the accuracy versus number of epochs, how the accuracy varies with the increase of epochs. First, this is the mural. This is for embed, XLMR, IndicBud, and DistilBud. So we can see a slight increase in the performance of the accuracies when each of the epochs, for each epochs, the model has been trained. And the loss, mural, embed, XLMR, IndicBud, and DistilBud. Here we can see the significant reduction in the loss when training the model. And memory utilization in terms of number of epochs. For every epoch, there will be a slight, very slight difference or increase in the memory utilization. Uh, IndicBud. So to conclude, Viral gave the best overall for Kannada due to an Indian language optimization. XLMR gave the high accuracy, robust, but it is a resource insensitive. IndicBud and DistilBud are efficient and suitable for real time, but the results or the accuracy is less. And embed is a general purpose, but not well suited for Kannada. And here to conclude, we can tell that um, if you want to get a better accuracy, use the resource rich, sorry, uh, use the heavier models for the better accuracies. If you want in the real time, use the IndicBud and the DistilBud models. Thank you. These are a few of the references, and thank you.